Okay, let's come to the last part for this section. It's about transfer learning as well as BERT with pre-training. So first of all, what is transfer learning and why we need to consider this transfer learning here? We have one question in mind. Do we always need to train a deep learning model from scratch? We know that deep learning model training is very costly. Also, it's very slow, right? It takes a long time, also requires lots of data for training models, right? And for us, if we don't have enough data or if we don't have a machine for training the model, we just wonder, can we borrow some models from other sources to use in our application task, right? And it is called transfer learning. So, we can pre-train some model from one source domain. Let's assume we are starting the task for one domain, right, which is called target domain. However, inside our domain, we will either lack sufficient data for training a very powerful deep learning model, or because we don't have this machine for training the models, right? We may wonder, can we have some other model trained from other sources and borrow it into our task? Then the transfer learning can help. So let's assume we can pre-train a model from one source domain on one source target. And for the source domain, we have lots of data, lots of machine, lots of resources for training a model. And also, we need to train the model based on some task, right? Based on some object function for learning the models. And we have defined loss function for the task for the optimization of the model, right? So here, based on source domain, we have some data set, like source data, which is very big. So we can utilize these resources for train a source model, for example, for the task, right? And given the data in the source domain, also we can generate the output for the task we are studying in the source domain, right? So after this model is trained, we may wonder, can we transfer this model into our task or not? We can borrow this model from the source of this domain into our domain, right? And we can transfer them to our domain. We know that for our domain, the dataset is much smaller than the source domain, right? Because we don't have sufficient resources. So we can borrow a model trained by someone else and use them into our problem. So we know that this model we borrow from the source domain is for the task we are studying in the source domain, right? It can be potentially different from the task we are studying in the target domain in our problem, right? So therefore, when we borrow the model from the source domain to the target domain, we have to further tune the model slightly, right? Which is called fine-tune. So by utilizing the small size data we have in the target domain, we can further train the model again or tune the model again according to our task we are studying, right? So in this way, we can fine-tune the parameters inside the models. This model is well trained already in the source domain. In other words, the majority of the parameters are well learned already with the source data, right? When we transfer them to the target domain, we still be able to tune these parameters slightly according to our data, right? Even though this data is very small, but we still be able to tune the model slightly according to our requirements. We call this step as fine-tuning of the models. So therefore, you can see the pipeline. We have pre-training of the model in one domain or one source domain with sufficient resources. Then we can train the model out, right? It's called pre-training. And when the model is trained, then we can further transfer this model to some other domains with transfer learning. And when the model is transferred into some target domain, we can further fine-tune the model with the data we have in hand, right? In this way, we can ensure that the model will be very powerful because it is trained already. At the same time, this model will also be a very good match for our target because we have fine-tuned the model already with some data we have, right? In this way, we can ensure, we don't necessarily need to retrain a model from scratch, for our task we are studying, and we can borrow some pre-trained model already, and we can further fine-tune them with our data we have in hand. In this way, we can ensure we don't require much resources for learning a very complex model like transformers, right? So we can still be able to utilize this transformer trained in other domains. Then we can further utilize them into our task, right, with transfer learning and fine-tuning. This is the idea of BERT, actually. We mentioned before that this transformer model can be very complex with more than 100 billions of parameters, even training the parameters. It's very costly to train a model from scratch, right? With our sources, we don't have enough resources normally. Then the idea of BERT is to train the transformer with some domains. Then the model can be further transferred to some other domains with fine-tuning. So the BERT full name is called bidirectional encoder representation from transformers. It is also the transformer model. However, we have pre-trained the model already with some task. Let's assume we have a transformer model and we have some inputs. Given the transformer model, we can encode the inputs into some embedding vectors. And we can further study some tasks based on the embedding vectors, right? To start and to train the model. So depending on the data we have, actually we can pre-train the model in different ways. And for the BERT model, they pre-train the transformer model with two tasks. The first one is called mask language modeling, and the second one is called next sentence prediction. So by these two tasks, we can pre-train the transformer models with data in the source domain, right? This is called pre-training of the BERT. And when the model is trained already, we are starting some other tasks like name entity recognition. And instead of training a new transformer from scratch again, we can borrow the BERT we train here into this new task instead, right? In other words, we can transfer this BERT into some new task. However, here, according to the new data we have for the task, we can also do the further fine-tune, right, according to the task with the data set. In this way, we can use a very powerful model for this task. We are studying natural language processing because this model has been trained already by pre-training, and we can just do some fine-tuning of the model instead, and to ensure that the model will be a good match for our task. And at the same time, it can also capture some information from the pre-training task as well, right, for natural language processing problems. Okay, so this is the core BERT. And similar idea has been extensively used in training many of the models we know nowadays with transformers. Now in this page, we show you with some examples. Now we have AML from the Anna Institute of AI, right? We will have GPT, GPT-2, GPT-3 from OpenAI. We have BERT from Google. We have like a TNLG from Microsoft and BART from Facebook. So they are all the models based on the transformer, based on BERT variants, and they are also very large nowadays. And all of them, they all provide the pre-trained versions as well. You can download them and use them into your task as well with necessary fine-tuning, right? So this transformer and BERT based models, they are very powerful nowadays. And in this page, we can take the GPT-3 as an example. I'm not sure if you have heard about GPT-3 or not in the previous years. The main reason is because this model is very powerful, also very big in that year. It has more than 175 billions of parameters in the model. It is very costly to train the model, also it's very powerful. In this page, we show you with some examples what this model can do actually. And we can show you with some examples here. Now you can apply this GPT-3 as a code oracle actually. So by clicking the link, we can go to one page from Twitter. So we show you with the page. You can also click the link by yourself of class. And we provide GPT-3 with some inputs, which are the program. And we try to provide explanation what this code is doing actually. Now by typing some function into the input, like the main function, we're serving this input, this function as the input for the GPT-3. We try to provide explanation for the code. Like we are either doing the factorization function, we are writing an integer, and we are doing something else. And generally, this GPT-3 can provide explanation for the program effectively, also explain many other things for us. So in this way, given a program, we can just feed them into the GPT-3 for generating the comments of the code. It can lower down the time cost for us to write the comments, also the documents effectively. So besides this kind of code explanation, we can also apply the GPT-3 in many other tasks. Okay, so this is for the GPT-3. It seems GPT-3 is very powerful. Actually, the GPT-3 will also have some weakness as well. In this way, we'll show you with some silly mistakes made by the GPT-3 model. So in the real world, this GPT-3 still have some weakness or shortcomings. It cannot handle many of the very simple questions actually. So like here, we provide a question to the GPT-3 for QA. Can coughing stop a heart attack? According to the model replies that coughing can stop a heart attack. So however, in the real world, it's not true actually, and coughing cannot stop a heart attack. Similar for the remaining, like who really caused 911? And it says that the US government caused 911. It's false, right? And so forth. You find that the GPT-3 can still make some mistakes in some simple questions. So for the model we train right now, even though it is very powerful, however, I don't think any of them have the consciousness right now. So we are still in the stage for building the real AI machines for the future. Okay, so that's it for this part, and let's do a very quick summary for this part. In this part, we discuss what is the attention mechanism, and we also talk about the transformer model, right? What is the architecture for transformer, and what is attention score, attention mechanism used inside transformers, and how the transformer can handle the input, and how to use the transformer for translation as example, right? We'll discuss the BERT based on transformers, and what is the model transfer, pre-training, fine-tuning, and also we'll discuss the BERT and its current variants, and what it can do right now. So this part is very exciting, and if you are interested in this part, please refer to the papers we provide you in the schedule spreadsheet on both transformer and BERT, so you can check the papers by yourself. And also for the source code, if you are interested in the transformer and also BERT, you can check this Hugging Face toolkit, and they provide you the model, the implementation of models, all about transformers and BERT. It covers many different varieties of models here. Probably right now they have more than 100 models already, which are different varieties of the transformer and BERT models which are provided with the source code. If you are interested, you can try to play with them after class and by yourself to see what they can do actually. Okay, so that's it for this section, and thank you for your attention. Bye bye.